Hello everyone, my name is Shambhavi. Hope you all are doing well. So into this particular video today, I'll be discussing about the different types of the queues that we have up into your Python programming data structure, right? What are the types we have in, what are all those used for, in which scenarios are they used, and basically how to implement those queues, right? So we'll be discussing all of those respective things in detail into this particular video. So let's get started up here, guys. So as we all know about the queue, okay, what I'll do, I'll like start writing up the things as well over here, so that we can even have the proper notes of the things. Right, so yeah, we all know about the queues, already discussed up into my previous videos. A quick recap for the same. So queues, those are sort of a linear array structures that actually follow up a type of particular order, right? That is either FIFO or LIFO, first in first out, last in first out, right? That is what is the orders that these two things are actually following in. So now with these orders which we have in, that is what is into a queue, right? So basically if the element is entered first, so it will first go out, right? If the element is entered last, so in that case it will go first out. So that is what it is all about, right? Now basically we are having in total 5 types of queues, okay? So I'll just write over here the 5 types of queues we are having in total, okay? Now what I'll do, I'll just make in the multiple comment so that every time I don't have to do, yeah, perfect. So there are total 5 types of different queues which we are having. So number first queue which we have up over here, that is your input restricted queue. Okay, that is the very first. Okay, let me correct the spelling for the same input restricted queue. Okay, the very first type of the one. Okay, so into this between I'll just write that this is a simple queue. Okay, we can just write it like that as well, so that it gets in a idea about this particular queues. We'll be discussing all about in detail about the ones, right? We'll be discussing very much detail with the practicals and everything, but for now we can just write up in this burner that it is an input restricted queue, okay, and that is actually a simple queue, right? The very first type. Second type which we have up over here is your output restricted queue, right? Output restricted queue, that's the second type of queue which we have up. And for this also we can just write that this is also a simple queue, Q-U-E-U-E. Well, it's also a sort of very simple queue, right? So yeah, first one is my input, second one is my output. Now the third type of a queue which we are having is your circular queue, right? That's the third type of the queue which we have it, which is basically your circular queue, right? Okay, number 4 we are having double ended queue, right? Double ended queue, that is also called as your DQ. If you have like watched out my previous videos in detail, so there you might have heard about this DQ as well, because I have discussed about that a very little. I just think I have just took the name only, but yeah, we have this double ended queue, that is your DQ into the previous videos also, right? So yeah, that is the fourth type of the queue which we have up over here. And the type number 5 we have in is my priority queue, right? The point number 5, the type number 5 of the queue which we have is your priority queue. Now this particular queue is as well divided into sub 2 parts. First one is ascending priority queue. First one is my ascending priority queue, and my second option is the descending priority queue. Okay, queue, right? So yeah, first one is my ascending priority queue, and the second one is my descending priority queue. So yeah, we have these 2 types of queues over here. So in total, as I told you, we have in total 5 queues: input restricted, output restricted, circular, double ended, and your priority. Right? These 5 types of the cues we have up all over the things. Now, as I talked over with you people that what Q was actually a very linear data structure, right? That actually follows up a very simple and a particular order, right? In which basically what are the operations we have in, all of those operations are completely performed, right? Now, as I was talking about, the order is your first in, first out. FIFO, first in, first out, right? So, um, example for a queue could be actually that if basically if a consumer is there, right? Now, whatever the resources consumer given, that consumer is going to consume whatever is first of all first served to you. Okay, let's say there are 5 dishes. The first dish is whichever is served to you. First of all, you take that dish only, right? Then you'll proceeding to the second, third, fourth, and the fifth dishes like that. So that is what is your first in, first out thing. Okay, perfect. So here we are having this first all the 5 types of cues which I have mentioned it up over here for you all. Great. Now what I'm going to do is I'll simply write down all of my the definitions and what are those respective ones and all about the same things. So I'll start with my circular cue because that's 1 second. Okay, great. I'm gonna start on with my circular cue because that's gonna be a little bit simpler rather than all my other of the cues which we have in. So if we're talking about my circular cue, so circular cue that is actually a linear data structure. I'm gonna write DS simply over here. Okay. So yeah, circular cue. That circular cue it is a linear data structure, right? In which the I'll go down. In which the operations are performed based on FIFO. That is basically a first in, first out, and basically what happens then, the last position which we have then the I tell you that how or why is it called a circular. Okay, so the last position to make the last position is connected back to the first to make it a circle, right? Now that is the reason it's called circular cue. What happens up over here, that what are the operations you have in that are performed based on first in, first out method only. That is the common in the queues, right? But whatever the last position you are having in, right, that particular last position is completely connected to the first one. The last position is connected to the first position, and that all is completely made out as a circle, right? So last position is connected to the first position and a complete circle is being formed up over there. So there is one more name which is actually called in for this particular, I'll just write in. It is also called I'll just write in caps, ring buffer. Okay, so this circular queue is this particular process now that happens up over there about the last position getting connected back to the first position circle is one. That is known as a ring buffer. Okay, now if I'm talking with you that when do you use up this circular queue, now you know very well that what a circular queue actually is, right? That's quite very much clear to you right now, I guess. Now the thing comes that when to use it all over around, right? What's the case or what's the scenario when you use up this? So I'm going to write the first one over here as memory management. That's my very first criteria which we have up over here. That is my memory management criteria, Right, into that what happens? What are the unused memory locations we have in, whatever are the unused memory locations, um, in the case of ordinary, okay, one second, let me get down. Okay, hold on. One second, in the case, and I'll just gonna go over here. Great. Yeah. So what are the unused memory locations we are having in the case of the ordinary queues? Right. Now, that can be utilized in your circular queues, right? So yeah, that is the very one thing which we have up over here, the memory management thing. So here, whatever the unused memory locations we have up into the case of your ordinary queues, means into your very simple queues which we have in, okay, in those queues, whatsoever is the unused memory locations, that can actually be utilized into your circular queues, so that if there is any memory which is empty, or if there is any sort of a space left out there in between, that can completely be utilized for the further processes as well. That is the very first scenario, or I'll say that is the very first case where you use up the circular queue. Okay, talking about my number 2, point number B. Okay, that is my traffic system. Okay, that is my traffic system. Now, if I talk about in a computer controlled traffic system, circular queues, these are actually used for switching, SWITCH. In that case, it is used to switch on the traffic. Excuse me. So yeah, into a computer controlled traffic system, the circular queues which we are having, those are used actually to switch up on the traffic, to switch on the traffic lights. One second, traffic lights one by one, repeatedly, repeatedly, as per the time set. Okay, what happens? Traffic system means that about that whatever the like multiple values we had put in, right? So based over all of those, so what happens that in a computer controlled traffic system, what are the circular queues are there? These are completely used in to switch on the traffic lights one by one repeatedly as per the time set. Right? That is where a circular queue is used. Now, if we're talking about in a general example for the same, right? So we all know about the traffic lights, right? So basically, after some seconds, around let's say 60 seconds, so the traffic light automatically turns red. Again, after a 60 seconds, the traffic light automatically turns, let's say, green or some things like that, right? It repeatedly works over. So that is a real example for the traffic system which we can relate up here from the circular queue. So there, what is happening? A sort of a circular queue is actually being done, and it is given in the different sort of basically the time, that after this particular time this switch has to be turned on in the traffic light, or after this particular time that switch has to be turned on traffic light. So this is all how this traffic system thing works in the queues, right? So yeah, in the circular queue it's quite easier, so that because you are having up a circle which is being made up, it's just that once you have to put up the times and set down the timers, and further things can be automatically done because yeah, it's a circle, right? So it will automatically rotate and go, and from one place to other it will automatically go. So in that respective case, you do not need to have any other thing, right? That is the thing which we have up over here. Now if I talk about my point number C, that is my CPU is scheduling. Right, if I talk about the CPU is scheduling, now what happens into this particular thing? So just let me scroll down a little. Okay, 1 second. Great. So yeah, talking about the CPU scheduling, so here whatever the operating systems we are having, operating systems. Okay, 1 second. Right. So operating systems, whatever are we are having, they often actually have to maintain a queue, a queue of processes. 1 second, let me get down. A queue of processes that are ready, to execute, or that are waiting for a particular event to occur. Right, and that is what over here we are having CPU scheduling. So operating systems which actually help us to maintain a queue of the processes. So those all of the ones are ready to execute, and they are waiting for the particular events to occur. So here the CPU scheduling and all those things, even they work much more faster rather than the others as compared. Right, so these are some of the reasons, or also these are some of the benefits that why this circular queue should be used, and what is it actually, and everything. Right, so I hope I am pretty much clear, and there's one important thing about the same, and that is the time complexity of this particular one. So I'll talk the time complexity. Time complexity is basically your big O of 1. 1 second, like that. Right, so yeah, that is your time complexity which we have up over here, your big O of 1. So this is what we have up over here for the same. Now we can talk a little bit about your practical implementation of the circular queue as well, because that's one of the important aspects which we can discuss over here. Right, so let's write some practical codes for the same. So for my practical implementation of my circular queue, I'll just help you to understand how the things works and everything. So I'll just try to first of all make a class. Okay, the name for my class can be my circular queue, right? My circular queue and my brackets. This could be a class. Now getting inside that, I can define in my init function. So def underscore init. And this, yeah, we know that self is automatically passed. With that, I'm going to pass a parameter that is simple k. Right, getting over here, I'm going to write self.k, and I'm going to assign that as k only. Right. Now I'm going to write, okay, 1 second. I'm going to write over here, basically your self dot, let's say q, because yeah, that's a q, right? So yeah, self dot q, it's gonna be equal to none multiplied by k, right? That is what we have up over here. Going down, 1 second, yeah, going down here we are having self dot head, right? And that is equal to self dot tail, which is equal to your -1, right? So I am having two things. One is my self dot head, other is my self dot tail, and both of them I have just simply stored over here as -1, let's say, right? I am gonna make one more function def. This time let's say it's enq, my function. Okay, bracket self will automatically be passed because I am making a function inside a class. Okay, and let's say this time I have a parameter as your data. Okay, so what I'm going to try to do over here is that I'm going to try to insert an element into my circular queue. That is what is my main motive. Fine. So I'll put in some conditions also, that if self dot tail plus 1, okay, If this is the respective condition, let's say is 10%, we have self dot k is equal to self dot head. Right, so what I'm just trying to do is my tail plus 1% of self dot k is equal to self dot head. So in that case, I'm actually printing and checking the full criteria where my circular queue is getting filled up. So I can just write over here that the circular queue is full. Right, now that's what I have up over here. Getting down, I have the condition of my elif. Right, elif into the bracket. I have self dot let's say head. Now if I have any condition for my head, let's say as -1, right, in that case, let's say my self dot head is going to be 0. My self dot head is going to be 0. My self dot tail is as well going to be 0, right? And I'm just going to write up over here like self dot, I have q, and here I have, let's say, self dot tail, right? Let's say that's one sort of other thing which we have up. So self dot q in the bracket self dot tail, and that I'm going to set to as a data. Data is one of the variables which we have already taken up above, right? Great. That is my elif condition. And moving further, we will be having up the condition for my else part, right? So into my else part, I can just write in for something like self dot tail. If that is now equal to self dot tail plus 1, right, percent of your self dot k. Now if this is the respective condition, in that case it will be self dot q. I'll try to make in a q for the same. I'm going to write self dot tail, and that is equal to my data. Okay, so self dot q. Okay, 1 second, brackets are wrong. I would put the large over here. Fine. Great. So yeah, we have this conditions set up for us over here. Now next thing which will go is I'll be now writing up the code for if you want to delete out any element from the circular queue. Now this was for inserting, right? This was for inserting all over. Now this time we have it for your deleting of the element, right? So yeah, here I'm gonna make in a new function, let's say def, and yeah, for deleting we'll write up dq. Okay, self will automatically be passed. Getting down, I'll start applying my conditions that if self dot head, if that is equal to 1, right? Now if it is only at the position 1 only, so at that particular place, very simply we can say that okay, it is completely empty. So I can just write that thus the circular queue is empty, right? That thing we can write up over here. Next we are having up over here as elif, right? Now elif self dot, we have head, self dot head, if it is equal to self dot tail. Okay, so self dot head is equal to self dot tail. Now here we are having temp, right? So temp is equal to, it will be self dot dq. Okay, self dot dq, sorry, not dq, it will be my q only, self dot q, because we are trying to delete up the elements from my circular queue, right? So yeah, large brackets, we have self dot head over here. Getting down, I have like, let's say, self dot head, okay, and yeah, okay, here we are having self dot head, and the value for the same is equal to -1. Okay, getting down, I have, let's say, again, 1 second, again I have something, let's say, 1 second. Okay, yeah, Here we are again having, let's say, self dot tail, and that is again equal to, let's say, minus 1, right? Now in that case I will return 10, because yeah, in that case I know that this particular thing is not empty, my circular queue is not empty, so I have something. Okay, now getting down, I'll be writing up my else part for the same. So else my temp will be equal to 1 second, yeah, okay, else my temp part will be equal to, let's say, self dot I'll be adding that q function over here, right? And into the bracket I'll be again writing self dot head, right? Getting down, that my self dot head which I have declared, now that value we are going to put up. So okay, it's equal to self dot head is equal to, we have here like self dot head, or we have +1 also, percent yourself dot k, right? That is what we have up over here. And now I'm going to return up the k, or no, not the k, I'm going to return up the temp, right? So yes, that is all about writing up, basically defining up the function for the deleting up of my elements from my circular queue. Now the third will be my printing the queue. Okay, so it's gonna be def, it will be print q, right? Bracket we are having up the self. Now my condition will go that if my self dot head, if that is equal to my minus 1, right? My very first condition, that if self dot head, if it is equal to my minus 1, in that case what I can print up here that no element in the circular queue. Okay, 1 second. So yeah, def print q, and bracket I have self. So if self dot head it is equal to minus 1, so into that particular case I can simply print that okay, there is no element into my circular queue, right? Okay, otherwise my elif condition will go, now elif it will be self dot tail, right? If that is greater than equal to my self dot head. Now I'm trying to put up the conditions between the tail and the head as well. So if the self dot tail is greater than equal to self dot head, in that case I'll apply my loop, that is for I in range. Okay, for I in range I have self dot head, comma, I even have self dot tail. Okay, 1 second, self dot tail. So for I in the range we have self dot head, comma, self dot tail as well, +1, right? And now I'm gonna print up all over here, print, I'll be writing self dot q. Okay, self dot q, in the brackets we are having I dot, I'm not gonna do up over here as end, and now that is equal to given the blank space between the ones. Okay, not dot, 1 second, let me put up a comma instead of that. Now perfect, right? So if that basically, if it is greater than that q values into that particular similar thing, right? Great. And after that I'm going to print up a blank space. So print a blank space. Okay, getting down, will go my else condition. Now let's try to print up the else condition. So it's gonna be like for I in the range, okay, for I in range, in the bracket we have self, okay, so for I in range, in the bracket we have self, comma, sorry, not comma, we are having dot, self dot head. Okay, 1 second, right? So for I in the range we are having self dot head, right? And even we are having self dot k. Now let's get down and just let's try to print it out our loops whatever we are having. One second. Great. So now I'm having up over like print. I'm gonna write self dot q. In the bracket we are having your I, right? Comma, I'm gonna write and I'll be giving the space at the end, like that. More down, I'm gonna write again for I in the range, okay. In the bracket again, I am gonna put up my condition. It will start from 0. It will go self dot tail plus 1, right? And putting up the brackets all over again. And I'm gonna print up the other thing. Let's say that's my self dot q, right? In the brackets I have over here like I, comma, I'm gonna write up end is equal to, and I'm gonna put up the blank spaces. That's all over. And coming outside my loops, I'm going to simply print up the blank, right? Now this is all what we have up over here. Now my all the queues and everything has been created, and everything, all of the things have been gone up over here. So now I'll just completely come out over here and I'll just try to create in the object and put in the elements into my queue. So we do that by obj dot enqueue function, queue. Okay, that is respective function. Okay, hold on. First of all, what I'll do, I'll make the object for this particular class. So let's say it's gonna be obj is equal to my circle. Okay, let's say I have 5 elements. So I'm gonna write obj dot enqueue, and into bracket I'm gonna put up the first element. Okay. Next, let's say I am having obj dot enqueue again. I'm going to put up my second element. I'm having obj dot enqueue. I'm going to put up my third element. Next, we are having obj dot enqueue. Again, I'm going to put up my fourth element. Further, I'm having obj dot, this time again enqueue, and I'm going to put up my fifth element. Right, now that's all we are having over here. This time I'm going to print up the initial queue. Right? And here we are having obj dot I'll just call this print q function, right? I'll just call out this particular print q function. Now even I'll just use up the dq function as well, so that it stops up at that particular position only, and I can print in up a sentence that print basically after, let's say, print after moving an element from the queue, right? So after moving an element from the queue, and I'm gonna do that calling the function obj dot print queue. Right, and yeah, that's all about my complete program which we have up over here. Right, so into this one, what we did, it was quite little lengthier, but yeah, everything was explained very clearly into this. So for my circular queues, I simply have made a class for that particular one, right? We have initialized out the class for entering the elements, then dq was for taking out the elements, and then print q was for printing out my elements. Now this time it's time for running it out. I'll just try to comment up the above things which we had in previously. And okay, let me do for this also. So okay, I'm gonna select it all over. Fine. Now we'll run out this sort of the one, and let's check in that how will this actually work out. Okay, so the file is my queues file. 1 second. Okay. So it will be okay. My circular queue takes no arguments. Okay, fine. Let's check in that what's the error over here. Okay, obj is equal to my circular queue, obj dot nq, right? That's the correct thing which we have done in. So my circular queue, okay, let me just go above and check if I have declared up everything correctly. My circular queue class. Yeah, that all is quite correct. And 1 2 3 4 5, we are just like, okay, I'll just try to do one thing. This print queue, it might not basically work, so I'll just try to change in the name for this particular function for now. CQ, like that, right? And yeah, now this will work completely fine. And yeah, it's all over the correct code for entering in my all the values which we have up over here into this particular one, right? That's giving in my the correct things, basically the correct values for the same. I'm going to remove this from here, and yeah, it's all good for my circular queue, right? So yeah, this was what was my circular queue which I was talking in all about with you, that this queue, the circular queue, is having up lots of benefits as well that I have already discussed in over here, right? Great. So after my circular queue, I will discuss in about with you the second type of queue which we were having. That was my, okay, 1 second, input restricted queue, right? That was my input restricted queue which we were having for the discussion of the second one. Okay, talking about this input restricted queue. So if we're talking that what type of queue it is, so in this, the input can be taken from one side only. Okay, I hope I have told about the front and the rear things to you people, and the queue queue which we have discussed. Let me show you. Yeah, here we discussed the front and the rear two things, right? So front was where we get the front item from the queue, and the rear was from where we get in the last item from the queue. That were the two things which we have it, right? So yeah, now it is input restricted queue. The input can be taken from one side only, and that is my rear side. One side only, it means my rear. 1 second, right? That is the one thing which we have up over here, that or the input can only be taken from one side only, and deletion can be done from both sides, basically from your front as well, and from your rear as well, right? That's one thing which we have up over here very clearly in the basically your input restricted queue, that whatever the input we are having, that could be taken from only one side. Basically that can be your only and only the rear side, right? But the deletion of the elements which are over there, right, that deletion, that removing of the elements, those can be done in from both of the sides. Both sides means your front side as well and your rear side as well, right? So that is what we have. Now one more very interesting fact about this input restricted queue is that this kind of queue does not follow FIFO. Now this particular input restricted queue, this type of queue which we have in now, this particular queue does not follows your first in first out, that is your FIFO. That is one of the very strange things which we have up into this particular one, right? So this particular queue, when you can use this, so this queue is used in the cases where the consumption of the data. 1 second, let me get that data down. Okay, 1 second. Yes, the queue or this particular type of queue is now, this is used in the cases where the consumption of the data needs to be first in first out, which needs to be first in first out order. But um, but if there is a need if there is a need to remove the recently inserted element uh, for for any reason, for some reason, if it is very much needed that you need to remove up the recently inserted element in that particular case. And one such case okay case one such case can be irrelevant data, comma, maybe you're having some performance issue or anything like that, right? So yes, so this is what is the one basically that this particular type of a queue, it can be used up into the queue cases wherever you are having up a consumption of the data, right? First of all, that needs to be in the FIFO order, first in first out order. But if there is any need to remove the any recently inserted element for any reason, right, in that particular case, yeah, this could very clearly be used out, that is your input restricted queue. It can be very simply used out. And the other case could be about all about your irrelevant data, or maybe any performance issue or anything like that. So that is what all is about, this input restricted queue, which we have up over here, right? Great. So what I'm going to do, I'll give you a very quick recap of whatever we have discussed up till now over into this particular video. So we started on with your queues, that what are the queues. So where we discussed that it is a sort of a very simple linear data structure that follows in your first in first out, right? In total, we are having over here as 5 types of queues, right? First one is our input restricted queue, that is a very simple queue. Second, we are having up your output restricted queue, that is as well also a very simple queue, right? Third, we are having a circular queues. Fourth, we are having a double-ended queues, those you call as DQ also. And basically on fifth, we are having up your priority queue, that is basically your ascending priority queue or your descending priority queue, right? So the very first one is my circular queue. So into that we discussed up that it is a very linear data structure into which the operations which we are having, those all are performed based over your first in first out, right? Then the last position which we are having, that is completely connected back to the first to make it up a circle. I told you, right? If it is circular queue, so yeah, for sure it will be making up a complete circle. So that when it goes to last position, it gets connected to back to the first. That particular whole process is known as a ring buffer, right? Now talking about your memory management. So whatever the unused memory locations we have up into the case of an ordinary queues, all of those can be utilized in the circular queues very clearly, right? So that's the one thing which we have. Next, we're having a traffic system as well. So into a computer control traffic system, what are the circular queues we are having, which are used to switch on the traffic lights one by one repeatedly as per the time set. So yeah, that is one of the traffic system, is one of the other advantage. Third, we are having a CPU scheduling. So there we are having the operating systems which often maintain up a queue of a process, basically that are ready to execute, or those are waiting for any particular event to occur or anything, right? The time complexity is big O of 1, which we have up over in the circular queues. Now here what we did, we simply made up a class named as your my circular queue, right? Into that we initialize up a function def init, right? Okay, 1 second, init init. Okay, yeah, this one. Great. Then we are having your self. We just defined out the k, we defined out the head, we defined out the tail, right? Then with the help of my enqueue function, what I was trying to do, I was simply trying to basically enter up the elements or check in some of my conditions which we have up. Is my circular queue full or not? If it is not, then we were trying to fill up our circular queue, right? Then we made a function dq. With that dq function, we're trying to like check if my circular queue is empty or not. So yeah, again for the same, we have used up some sort of conditions which were over here. And next, what are you trying? We're just trying to print out our queue which we have in. So for that, we made up a function print cq, and that was helping us to do the same thing. Further, we made up an object for my queue, obj named. We just put down the 5 elements into that. We printed the initial queue, and after removing the elements from the queue. So what I can do, we can just try running this once over here. 1 second. We can click over run, and might see here we are having the initial queue as 1 2 3 4 and 5, and after removing my element from the queue, we are having 2 3 4 and 5, right? So it's just that my first element has been removed up from here, and that was already done with my dq function, which 1 second, yeah, this dq function where we have this simply divided and removed out my element from there. So that is what completely like is my circular queue. It is all over the circle, and into that whatever the elements were entered, they will be deleted, and all of those respective things. Second type of a queue which we discussed was your input restricted queue. So this in here input can be taken from any one side only, that is mainly means your rear, and the deletion can be done from both the sides, either your front or your rear portions, right? So now here this particular kind of a queue which we are having, this completely does not follows the FIFO. Okay, it not at all follows up the FIFO. So here the queue which we are having, it is used up into your case where you need any consumption of the data, right? If it is needed, needs to be in first order. But if there is any need to remove any of the recently inserted elements for any reason, right, in that particular case, it can be irrelevant data or any performance issue, etc., or anything like that. So in all of those respective in cases and scenarios in this input restricted queues, this is all how it can help us all around, right? Great. So I hope I am pretty much clear with this two types in details to you about the circular queues and the input restricted queues. The rest left out 3 queues which we are having. Let me show you the name for those all. 1 second. That are your output restricted, double-ended and priority queues that we will be discussing up into my further next videos, right? So I hope you might have learned a lot of from this particular video, and you might have got a lot of details and information about the queues. That is one of our very important data structures for cracking up your any of the MNCs or anything like that, right? So I hope you might have got a very clear idea about the same. If you have any questions, you can always put them down in the chat box for me. I'm really happy to send the comment section. I'm really happy to answer those for you. And if you haven't subscribed out my channel, do go ahead and subscribe out the channel. Even share it with your friends so that they can even start learning DSA and crack in their job companies. If you haven't liked out the video, do like this video and share it with your friends. This is all for this video. Till then, thank you and take care.